Hey, everybody, and welcome to another episode of Software to Find Everything, the podcast for smart world systems. Today, we're going to dig into one of the most talked about and often misunderstood topics in the automotive world, which is full autonomy. Even just saying it sounds like we're right around the corner, but in reality, it's a lot more complex than that. But I have Thomas Bloor here with me, Automotive Sales Director at RTI, to help me break it all down. So, without further ado, welcome back to the podcast, Thomas.
Yeah, thanks, Stephen. Nice to be back.
To start us off, based on what you're hearing from customer interactions and seeing at the big automotive trade shows, can you give us a pulse check on where we really are with autonomous vehicles right now?
Yeah, I mean, I think it's kind of a mixed bag a bit at the moment, right? I think there's some exciting developments in some areas. We've seen, GM sort of publicly pulling back from its cruise investment and, sort of shuttering that sort of robo-taxi investment that they had. Although now apparently they're sort of, taking some of those people and moving them across to sort of more passenger car autonomy, right? So I think, there's sort of three segments, if you like, of the marketplace you can think about. One is sort of the robo-taxi companies, right? So there you've really got, Waymo and Zoox who are still sort of like, going down that path. And, they're both running real cars on the roads, not quite commercially yet from a Zoox perspective, but they're continuing down that path. Then there's sort of the, I guess the mainstream automakers, so GM have, Super Cruise, Ford have Blue Cruise, there's obviously the Tesla sort of full self-driving stuff. And that's more geared around sort of hands-off highway autopilot, if you like. So it's not really full autonomy at this point in time. And then the last sector you've got a sort of commercial trucking, right? So there's people that are like, Torque Robotics, who are still looking to say, hey, can I take the driver out of the truck and have, basically autonomous 18 wheelers going from depot to depot. And again, that is full autonomy, right? But it's kind of a simpler solution set, right? They're not talking about driving those in the dense urban areas. It's typically sort of mainly on the highway or from the highway to the depot sort of thing, right? So that's kind of the landscape at the moment. But the other thing that's happened, we can't get away from AI, right? Similarly at the moment, but AI seems to be sort of upending a lot of this stuff, right? If you look at some of the traditional autonomy approaches, right, they sort of say, well, they can meet about 40% of the use cases on the road, but if you architect autonomy with AI, those systems now supposedly can hit about 80% of the scenarios that they find on the road. So there's actually sort of some quite exciting advances in that sort of technology, providing a sort of quite a big leap forward in the autonomous technology that we're going to be able to see on the roads, relatively soon, I would say.
Yeah, I'm curious to know what are some of the biggest misconceptions at this moment that you see when it comes to full autonomy, whether it's inside the industry or just from the general public. What do you think people tend to get wrong?
I think right now, and I think maybe in the eyes of the public, there's confusion between what's ADAS, what's level two, what's real autonomy, right? So if I look at, Tesla's full self-driving, right? It's, arguably a level two, level three system, right? It's a, hands-on, highway autopilot, right? And I think the industry still has to sort of drive that message to the general public, right? There's different levels of systems, right? There's, hands on the steering wheel, eyes on the road, right? It'll basically drive the car for you, but you have to be ready to take over at a moment's notice. The next level up, right, is hands off the wheel, eyes off the road, right? And there it'll drive. You have to be available to take control again. But the handover period is quite long, right? It's going to be 10, 20 seconds before you really get your hands back on the wheel and kind of understand what's going on around you because you might have been reading a book or doing some email or something like that in the vehicle. So I think there's still sort of confusion um, with the general public, right? You see people posting pictures up on social media of them in the car, hands off. And it's like, well, that's not really a hands off, eyes off system. So I think there's some more education to be done there in terms of the public about what is available today and what or how they should be using it.
Right. maybe a level 5, a true autonomous vehicle wouldn't even have a steering wheel one of these days.
Well, absolutely. You look at Zoops, right? And they don't, right? So they're pure robo taxi, right? There's 4 seats in that. There's no steering wheel. There's no means of anyone in the car controlling the car, right? So that's obviously a full autonomous system, right? So.
Yeah, speaking of that, just a quick side note, just for our audience, can you tell us a little bit about where we are now? There's these levels that you were talking about, level 1 to level 5 being true autonomous vehicle with no steering wheel. Where's that sweet spot that we're living at right now? Is this level 2 on our way to level 3?
Level 2, level 3, right? So this is the SAE kind of levels of autonomy, right? They're sort of typically well known in the industry, right? We say, right, level 5 is full autonomy. There's no way for somebody inside the vehicle to control that. Level 2, level 3 is sort of typical of the sort of the highway autopilot systems that we see on the roads today, right? So level 2 is more sort of hands-on, eyes on the road, right? Level 3, and then you're getting into the sort of like the hands-off, eyes-off type systems as well, right? So that's really where we are. That's really where we are today.
So I'd like to pivot and talk a little bit about what's holding us back. So from your point of view, what are the biggest technical blockers that are still standing in the way of true autonomy? And what about it makes it so challenging to like pull off at scale?
And that's a pretty wide ranging question, right? So I think there's a number of things, right? I think, as I've said before, right, more traditional type of systems, or the way they've traditionally been done, only could cope with about 40% of the scenarios that you typically see on the road, right? So increasing that number was a fairly slow process. Now we seem to have this sort of breakthrough with more AI kind of route planning systems coming in that have now jumped that up to sort of around 80%, right? So there's that aspect of it, right? There's a number of other aspects as well, right? So there's basically silicon compute power in the car, right? If I look at the advances that the silicon industry has made over the last 10 years or so, right now we're getting to the point where I can actually get a full autonomous system and put it into one big ECU that will sit in the car because I've got enough silicon compute to cope with that. I think deeper into the system as well, right? Ensuring real-time performance, data distribution, sensor fusion, system latency, all these things. As the vehicle architectures have moved, right? Remember, we started trying to build these things where we still had a fairly distributed ECU type architecture in the car. As we're moving towards more sort of SDV type architectures, that helps us get there as well, because it helps make some of those things a lot simpler to kind of build out, actually physically put into the vehicle. So I think there's lots of challenges and there's lots of progress being made on all those fronts simultaneously.
Let's get into software-defined vehicles. How are SDVs changing the way OEMs approach full autonomy? I mean, it must be so much easier to build autonomy around an SDV than a ECU-centric old legacy architecture model.
For sure. Yeah, absolutely. Right. And I think, I just said, right, advances in silicon technology mean that I've got enough CPU cycles, to put into a sort of ADAS autonomy box that I would put into sort of an SDV type architecture. That sort of zonal control means that, I've got the signals, are much, much easier available to me as opposed to this old sort of distributed ECU type architecture. SDV goes hand in hand with OTA and sort of connectivity, right? So now I have the ability to actually go out and fix problems and update the car and keep these things much, much more up to date, right? So I think the big thing that's changing is that SDV architectures are enabling the continuous improvement of these systems once they get deployed, right? I mean, the sort of separation of the software development thread from the hardware, and so the increasing abstraction of the software from the hardware layers means that OEMs can invest in a software stack and an autonomy stack and have that across the range of vehicles and continue to improve that and then roll that out across generations in the future, which obviously sort of eases the investment burden from the autonomy perspective, because it costs an awful lot of money to try and make an autonomous vehicle.
And that actually brings us to a key piece of the puzzle. So how does RTI/RTI Connext support the shift to a more modular, scalable architecture?
Yeah, so yeah, RTI Connext, which DBS, right, is the underlying standard that we're using there, right? Helps in terms of moving the zonal architectures to more of a data-centric perspective, right? It's a bit of a mind shift, right? I mean, people have traditionally always thought about hardware-centric perspective, right? Okay, well, I'm going to build a system. Okay, how am I going to start? You know, start on the hardware layer, and you kind of build up from there, right? With sort of a data-centric mindset, right? You look at the signals that you've got available to you. And those signals are fundamentally available in any node or to any software application, sort of anywhere in the system. Um, and so once you do that, you kind of abstract yourself from the underlying hardware, and now you helps you make a software stack that is portable from generation to generation, and even across sort of models in the vehicle range, which then helps also with things like quality of service, cybersecurity built into those communication layers, help you build a very robust, reliable, real time data network that will enable the applications and the autonomy to be built on top of it.
I'm glad you mentioned zonal architecture. Clearly, a big trend in the next gen vehicle design. But how is that relevant to autonomy? This shift over to zonal architecture, and what makes OEMs see this as such a big game changer?
Well, so I mean, the industry has been struggling for a while, right? In terms of the electronics that are going into a car, right? Was really pushing the BOM cost of the vehicle, right? And we've all seen vehicle prices come up, and the cost of electronics and the cost of software is an ever increasing portion of that, right? As you move to a zonal architecture, right? I get away from this, myriads of ECUs, kilometers of wiring, in the vehicle to a much simpler, much cleaner kind of architecture, whereby I'll have a sort of a front zone, a rear zone, cockpit controller, this kind of thing. So I reduce cost. I reduce the amount of wiring. I kind of simplify that. Um, but then all those kind of systems talk over the same zone and the same sort of communications backbone, right? So it makes everything easier. And so therefore it actually reduces some of the underlying costs, which enables, there to be more price flexibility in some of the more advanced features. And as we have things like the European legislation that's mandating automakers support vehicles. As long as there's vehicles on the road, right, they need to have cybersecurity updates and software support from an OEM. It makes it much easier for OEMs to sort of build one kind of software platform that they can support their long term into the future and meet those requirements.
So, from your perspective, where do you see Connex making the biggest impact in the industry? And what are the areas where it's really moving the needle for OEMs?
I think real time data sharing, across that system, right? Obviously, that communications network becomes quite complicated. With all the signals, going to all the different zones. Right? You look at some of the architectures that have come out now. You've got 3 or 4, brains or central compute nodes within that, and all the zones are feeding those. Right. So I think supporting real time data sharing between those systems, meeting ISO 26262, which is the safety certification that you want for ADAS and autonomy, easily, right, running over communications bus, right? We can help you do that, and we can provide certified stacks to do that. That certainly is a big help. Quality of service, right? I no longer have to worry about writing quality of service code in my application. It's dealt with that at a communications bus layer. Cybersecurity, right? I can write a cybersecurity policy for the vehicle that I apply to the data bus across everything, right? So certain things, I would maybe want encrypted in transport. And certain things, I'm happy. I just want to have really good access control around. But as a cybersecurity engineer from my OEM, I don't have to worry about all my applications teams implementing the policy that I've told them they have to. I can actually implement a policy on the data in the vehicle, and actually even offboard in the vehicle up into the cloud, at the communications layer, at the DDS layer, without having to chase all these different applications teams and actually get them to replicate bits of code multiple times across different applications.
Do you think full autonomy is still the big end goal here, or are things starting to shift more towards smaller, quicker, faster wins, like getting L2 or L3 functionality dialed in first?
I Depending on industry segment, right? From a passenger vehicle segment, right? From a passenger vehicle OEM, absolutely, right? They're looking at highway autopilot, right? On ramp to off ramp. Can I build that out? Can I make that reliable? Can I make that truly hands-free, right? And then sort of incrementally sort of expand that out from there. Obviously, if I'm in a robo-taxi kind of segment, right, I need full autonomy. If I'm in the trucking segment, I need full autonomy from those perspectives, right? So they're still trying to jump to the end goal. I think from a passenger car vehicle perspective, right, we'll see increasing adoption and abilities of the highway autopilot systems in those vehicles.
I'd like to kind of tie this back to RTI and how we're involved. That being said, how do you see RTI's role evolving as OEMs get closer and closer to full autonomy and start thinking even beyond that?
So I think, we're evolving all the time, right? And our role will evolve, right? Obviously, right now we're focused on, reliable, secure data, connectivity in the vehicle. That'll extend up into the cloud, right? As we get more and more cloud connectivity, or even in the cloud as that data moves around the cloud, right? Digital twins, right? An interesting aspect of the industry whereby, your vehicle might have an exact digital twin in the cloud that is running all the time. And we can provide secure data sharing between those two things. Tooling, right? We already have AI-enabled tools or AI tools to help build, debug, and optimize the communication structures in these vehicles. I think we're possibly the first in the industry from a DDS perspective to bring those capabilities to the industry, right? So we're very much focused on how do we enable our customers and OEMs to basically move faster and build better.
Okay, last question here for you, Thomas. What advice would you give to automakers or suppliers trying to future-proof their autonomy strategy? If you could talk to all the OEMs and take the limelight for a couple of minutes, what would you say?
I'm not sure I've got anything dramatically full of wisdom to say, right? I think not just from an autonomy perspective, but I think from an SDV perspective, right? I think the best thing you can do to kind of future-proof is really kind of move into that data-centric mindset, right? The data is your system, right? Being able to get a hold of that data and use that data is vitally important, right? As you try and bring new features either to an autonomous system or an SDV, be it sort of a consumer infotainment feature, right? You need easy, instant access to that data, right? And that's really what we bring, right? Is that you can just subscribe the data, and any application can get the data anywhere in the system or up in the cloud. Easily, simply, and very quickly as well. Right? So that's a great advantage.
That's going to wrap it up for today's episode. A big thanks to Thomas for joining and breaking things down when it comes to autonomy. If you're building systems in this space, it seems like the move towards software-defined, modular, flexible architectures isn't just a nice to have. It's the future, and it's where we're heading. So again, thanks for the insight and for joining, and we hope to have you on again soon.
No problem. Thanks so much, Ryan.
Thanks, Thomas.